This is the intuition video for question 1C on the 2008 MAT paper. In this question we're given these equations. We're given cos kx minus sin k of y equals 2 and sin k of x plus cos k of y equal to 1. And we're asked for what values of k are these pair of simultaneous equations solvable. So we're going to try and imagine what this means graphically, but first we need to think, what does a pair of equations being unsolvable mean? So if we take two curves like this, two lines like this, these pair of equations are solvable because they intersect. However, if you take a pair such as this, these will be unsolvable because they're parallel and never intersect. So what we essentially need to do is take these two things represented as lines and show the two lines always intersect for all values of k if we want to show that this is solvable for all k. So let's actually plot the two lines we care about. So we've got k, which is theta in our question, set to be roughly 1.5. If we plot our two lines, we see, at least for this value of k, this system's solvable because the two lines intersect. Now let's vary k and see what happens. We see that for all values of k in 0 to 2 pi, this system's solvable. However, looking at this, you might have noticed something, that this intersection point seems to move in a strangely nice pattern, and indeed it does. Because algebraically we showed that the intersection point of these two equations in the solution video is this, which is parameterized by k. So let's mark this point on, and with a little bit of algebraic manipulation using the fact sin squared plus cos squared is 1, etc. If we plot this circle in the dashed line and vary k now, we see that the intersection point actually moves around the circle x squared plus y squared equals 5. Which is a very nice feature of these equations. And so we have our solution that for all k in 0 to 2 pi this system's solvable. However, there is actually a much nicer, easier way to do this that you'll learn at university using an idea called linear algebra and considering cos k minus sin k cos k as a matrix applied to a vector xy. If you want to look more about that, look at determinants and the ideas behind that and Gaussian normal elimination.